What do I know about you're raising your hand. What do I know about the length of GH? I don't want to know the number yet. I want to know, what do I know about the length? Connor.
It's congruent to the length of JH or whatever.
Correct. They're going to be the same length. So then as a class, what is GH going to be? 4.6. So GH equals 4.6. Number 2, it asks me for QR. Again, what do I know about the length of QR? Cooper. It's equal to the length of RS. Yep. So why do I know that, y'all? I said y'all. Why do I know that? The line in the middle is what? Is a bisector. Is a perpendicular bisector. Okay, so the length of QR is 1.3. Just make sure you're prepared just in case it ever asks, because it will. I know you haven't been asked yet. Like what the length of QS would be. Can someone tell me how I would find the length of QS? Yes, Kendall, we would add them together. So what is 1.3 plus 1.3? 2.6.
I don't know. Because that's
Dadgum.
and you said you were having
Yep. Number 3. Find the length of AB. We're going to do the same thing. What do we call point B? What is that one called? It's not the bisector.
the midpoint.
Is the midpoint. We're just not raising it. It's fine. It is a midpoint. So I'm going to set up. I know that 5x. I got to zoom in. 5x is equal to 4x plus 3. All right, so subtract 4x. 5x minus 4x is just x. Well, x equals 3. He's just ahead. It's fine. So we want to find the length of AB. The length of AB is 5 times x. Yeah, so 5 times 3, which is 15. Good. Number 4, this one looks weird, but really it's just a segment that has still been bisected. And there's a perpendicular bisector. So a point on the bisector to the endpoints is going to be equidistant. So we know 9x plus 1 will equal 7x plus 13. So what do I do first? Subtract 7x. I'm going to do 2 steps in 1 because of how little room I have. That makes 2x. I'm going to subtract the 1 as well. So 2x equals 12. So x equals 6. Got to plug it back in for UW. So 7 times 6 is 42. Plus 13 is 55. So yesterday we talked about 6.1. You see how it's really teeny tiny? We talked about perpendicular and angle bisectors. That's because today we're talking about bisectors in a triangle. Okay, that's our goal. So all the things we learned yesterday, they're going to be applied to a triangle like times 3, because there's 3 sides in a triangle, 3 angles in a triangle. We'll talk about it. So the whole point of this section is, and the next section, is to find the center of a triangle. So we'll go back. Nobody has been able to explain to me how we know the center of a circle is the center of the circle. Y'all, they threw out vocab to me. They have no idea what they're talking about, though. So, how do I know the center of the circle is the center of the circle? You can raise your hand. Oh, gosh. We'll go with, we're going to do Cooper first, though. Cooper. If I measure the diameter. Yeah, kind of. I mean, yeah, that's, I just want to explain, like, why the center is there. I know how to find it, but why? Why is the center there? I'm looking for Cooper. We could try Cooper for a second. Go ahead. Connor.
Hear me out. There's a center to everything. The center is there because
Connor.
you gotta have the perfect shape of a circle, or it's not gonna be shaped right, and it won't roll right or move right or anything. The circle is there because the circle is there. It's
Okay.
like, let's say you have a box. You're gonna have a
Lil-
center of a box.
Connor.
Lily.
I would say because there's no like sides to it or angles to it inside of it, so it would all be the same thing in the middle, I guess.
What does the center have to be? Stop it. What does the center have to be? How do I mean, guys, okay, what I'm looking for. You are.
Thinking it.
Perfectly in the middle.
It has to be perfectly in the middle. I will accept that. It has to be the same distance
Has to
all the way around.
be equidistant.
I thought
It has
you
to be
said you don't want
equidistant all the way around. Right?
Mm-hmm.
That's what you were kind of saying it, and then you were kind of that's
And
the
then there's
equidistant
just
all the way
Connor,
around.
there's a middle.
And then there's Connor. There's an inertia to it. So
You gotta put a nudge on the ball to make it move. That's how it works.
you know how many stories my husband hears about Connor?
Probably a lot.
Probably a lot of them. Definitely. Okay, and then to a square. Can anybody? This one isn't necessarily. How can I make sure that the point, the center, is in the middle?
Actually, no. I'm gonna answer this seriously.
Okay.
If you take what are the things called that we used yesterday? Or you take a ruler or something.
A ruler.
If you take a ruler and put it and perfectly line it up on the line, and you can measure all the way down, and it's like you did when we did the two things, and then there's the midpoint. Well, that's how you can find the midpoint of that, and then you can measure it across with the like this way lengthwise, and then you'd find the center. That's how you find the center of it. Yeah.
You cut it.
Yeah.
You're right.
Yeah.
Connor, you.
It's fine.
That's what I said.
So the issue is with a triangle. There's not one way for a triangle to look, right? There's a bunch of different types of triangles. So there's a bunch of different types of centers. One center is the same distance to all the sides. One center is the same distance to all the angles. We're actually going to talk about those today. That's our goal. Capiche?
Capiche.
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 You want to remove from your mind that the center is in the middle of the shape, because that won't be accurate. So if you think center means middle, it's not. Okay? So we're going to talk about, you see it on the screen, certain center, in center. Those are our two main words. But before we do, we're going to talk about the word concurrent. When three or more lines, rays, or segments intersect in the same point, they are called concurrent lines, rays, or segments. So concurrent. So where a bunch of lines intersect, it's called concurrent. Where they intersect, so like, popping up the picture. Where they intersect is called the point of concurrency. Don't want to pop up? Praying about it? There it is. Point of concurrency. So that is the next word. The intersection, or the point of intersection of the lines, rays, and segments is called the point of concurrency. You're learning 2 points of concurrency today. Whether or not you know that word.
Current, I did.
Not currency.
Current,
Concurrency.
like current of internet waves, electrical waves. I know that. Current.
Concurrent.
It's
Concurrent.
concurrent.
C-O-N.
Current, like
It's not
waves.
the
Concurrent.
same.
It's fine. We're not arguing about it. It's fine.
Just let it go.
It's fine.
You're smart.
Okay. Circumcenter is the first type of center. You have it written on your paper. I'm going to explain how the circumcenter is formed. It's formed by 3 perpendicular bisectors. So we talked about perpendicular bisectors yesterday. There are 3 sides to a triangle. Therefore, there are 3 perpendicular bisectors in a triangle. I will show them to you. So, first word is circumcenter. It is formed by perpendicular bisectors. And from the center, I'm just writing on the board, from the center to the angles is congruent. So we're learning 2 different types of centers. Yesterday we learned 2 different types of bisectors. What were the 2 types of bisectors? We already have one on the board. Perpendicular bisector, and the other type was angle bisector. So they both separately will form a type of center. Okay, so you're going to see both of those. I'll leave them at the top of the screen so we can reference them very often. But a circumcenter in specific, it is formed by perpendicular bisectors. So remember, what does a bisector do, y'all? It cuts something in half. So here is where a perpendicular bisector is. You got a side of a triangle. D is the midpoint. And DP forms a right angle through the midpoint. So this is a perpendicular bisector. So if you look, they've listed them here. You're going to take a highlighter. We're going to highlight the perpendicular bisectors. Okay, so we're going to highlight them. DP, EP, FP. Where they all intersect, this forms a circumcenter. This is called a point of concurrency because that's where they all intersect at point P. But this point of concurrency is called a circumcenter. So, do these look like they're the same length? Do they look like they're congruent? No, that's because they're not. But what is congruent, what we wrote down, from the angle to the center is congruent, or from the center to the angle. So from P to A, from P to B, from P to C. I'm confusing it with the colors.
It's two colors.
It's fine. It's fine. So P to A, P to B, P to C. So do you see what I have written at the top of the board, these three things? You need to memorize that. Perpendicular bisectors form a circumcenter. The circumcenter is from the center to the angles is congruent. You need to memorize that. This section is just a little bit of memorization. Okay? I'm going to show you why they are the way they are because it's hard just being told it. You can flip to the second page. You'll already have this picture on the second page. In a triangle, the three perpendicular bisectors are concurrent. The point of concurrency is called the circumcenter. I believe that's a blank on your paper. I'm going to show you what it looks like on these three different types of triangles. You've got a big blank. It says the circumcenter can be inside the triangle, on the triangle, or outside the triangle. So it can be inside the triangle, on the triangle, or outside of the triangle. And I'll explain why. I know, again, you think center means inside of the shape, but it doesn't necessarily. So it can be inside the triangle, on the triangle, or outside of the triangle. You've kind of already got the picture, but I'm going to show you why it is the way that it is. So a perpendicular bisector, you remember how you have a segment. So let's talk about this segment. A bisector is the midpoint on that segment, right? So what I'm going to show you is just plotting the midpoint on each of these sides. Okay? And then to have a perpendicular bisector, you have to have a line go through the midpoint and be perpendicular to the line that it sits on. So let's talk about this point. A line is going to pop up. So the perpendicular bisector, so it went through the midpoint and it forms 90 with this side length. Okay, so that's why there's three of them. You already have them on your paper. We're going to talk about what kind of triangle this is. What would we call this triangle? It's already on your paper. Other than that, it's acute. You've got it on your paper. So where do you think the circumcenter will be on an acute triangle? Look at where it's located right now. Here are the options. What did you say? Inside. So you're going to write the acute triangles always have the circumcenter inside. It will always be inside. Right triangle, again, I'm going to use a line to go perpendicular through the midpoint. Same thing here. Okay, so what kind of triangle is this? It's a right triangle, and where is the circumcenter here? On the triangle. Yep, we don't have to be that specific. We can just say on the side. Or on the triangle. Good, and then obtuse, same thing. a line perpendicular through the midpoint. So all three perpendicular bisectors. Where is the center here? On the outside. So for an obtuse triangle, it will be outside. And you're like, Miss Marshall, that does not make sense. I'll show you. So we said from the center to what is congruent? So at the top of my screen. From the center to what is going to be the same length? From the center to the angles. So center of the angle, sorry I can't draw, center of the angle. It's going to be congruent. So what I have in orange is going to be marked congruent. Whereas with an obtuse triangle, if I said the center was in here, is it the same distance from all of the angles? No. And there's not a way to place it inside of the triangle to make it the same distance to all of the angles. Does that make sense? That's why it has to be outside of the triangle. And then the same thing with the right triangle. So you do have to know this portion when a circumcenter is inside the triangle, when it is on the triangle, and when it is outside. Okay, so make sure you know that for your quiz. We're going to have a quiz. I think it's the Tuesday we come back from Thanksgiving. Okay. All right. So now we're going to talk about, we just talked about the circumcenter. It's where the perpendicular bisectors intersect. The distance from the center to the angles is congruent. It can be in, on, or outside the triangle. Now we're going to talk about an incenter. So we're on the same page. An incenter is formed by all three angle bisectors. So an incenter is formed by angle bisectors. And this time from the center to the sides is congruent. The center to the sides is congruent. So in our example, this one is saying the incenter of a triangle is equidistant to the sides of the triangle. So with one highlighter, we're going to highlight the angle bisectors. So angle bisectors, cut the angle in half. So it would be these. Do they look like they are congruent? No, that's because they're not. AP is definitely longer than others. But from the center to the sides is going to be congruent. That's what it just said. Equidistant from the sides of the triangle. So from the center to the sides is going to be congruent. So in that second color, you're going to mark from the center to the sides. Wow, look, the Miami Dolphins. You're welcome. No? Okay, so what would normally be here to show me that the angles were bisected? What would be in this picture? Raise your hand, Lily.
Isn't there like two lines that show that it's congruent?
Yeah, so you would have lines here normally, and the number of lines would match up. However, they told us, above it that it was an angle bisector. But here's also how you know it's not a perpendicular bisector. So remember a perpendicular bisector? What does it bisect? Like a line, right? So in a triangle, it'd be the sides of the triangle would need to be bisected. So think about this. Here's the side of the triangle. Does D bisect the side of the triangle? Is D the midpoint of the triangle? Or that side? No. So it can't be a perpendicular bisector because none of these sides have a midpoint marked. That one, you could probably mistake that to be the midpoint, but you definitely can't mistake F to be the midpoint. It's just not. So normally it would look like this, where you've got these angle marks. Okay. So in a triangle, the three angle bisectors are concurrent. So it means they all intersect. The point of concurrency is the incenter. The incenter, this is a blank, is always inside the triangle. So incenter, inside. So the incenter is always inside the triangle. Okay, so now we're just going to apply everything. We're going to apply it all. We have to decide first what kind of center we have. And in order to do that, we need to know if we have perpendicular bisectors or angle bisectors. So in this first one, can someone raise their hand and tell me whether we have perpendicular bisectors or angle bisectors forming point Q? What do you think? Connor.
Angle bisector.
Why are they angle bisectors?
Well, there's angles first of all. I see angles down on right there, and then I see an angle starting off at the top where it says KM. There's two angles up top.
You're saying these lines?
Yeah.
Okay, yes. Okay, sorry, you just said interesting. Correct. So we do have an angle bisector. So angle bisector means what kind of center do we have? An in-center. I'm just going to go ahead and write it up here so that we can remember. I know you can't see it in class, but I'm recording. So from the in-center to what is congruent? The in-center to the sides is congruent. Right? So from the center to the sides, it's going to be congruent. So let's highlight what's going to be congruent. QP is going to be congruent. It goes from the in-center to the side. QN is going to be congruent. And then QM is going to be congruent. So I know they're all the same. I know that QP is equal to QN and equal to QM. I know they're all the same length. But I was given QP, right, 2x plus 9. I was given QM, and they want me to find QN. So what do we think we can do here?
QP and QN are the same length.
Yeah, we could set them equal. They're the same length. So QP is 2x plus, don't write in highlighter. QP is 2x plus 9, and QM is 5x minus 3. Move the smaller x. Add 3. 9 plus 3 is 12. 5x minus 2x is 3x, so x equals 4. So then what can I do to find the length of QN? Plug it in. Which one do we want to plug it into?
QB.
Sure. We could plug it into either of them. So 2 times 4 plus 9. 2 times 4 is 8 plus 9 is, so QN is equal to 17, the length of QN. You could have plugged it in here too. Oops. Yeah, so 20 minus 3, you'd still get 17. So, both are correct. All right, the second, it tells me we have a circumcenter, but you really did not need to be told. Can someone tell me a reason, you can raise your hand, tell me a reason why it's a circumcenter and not an in-center? There's like 2 reasons. Yeah, it's on the side. The center is on the side. Where does an in-center always have to be? In the middle, on the inside. So it's definitely not an in-center for that reason. And then, Connor, what's the other reason?
There's a bisector that cuts the line.
Yeah, these cut the lines in half, yeah. Kind of. I mean, it is. But why is it not an in-center, other than it's not on the inside? What else?
We don't have an angle.
Yeah, you don't have angle bisectors. Was Z bisected? Definitely not. Was X bisected? Definitely not. Or if you even looked at Y, if you were offered, I'd be offended. If you were offered 2 slices of cake, sorry, you like pizza, one is obviously superior to the other, right? They're not the same. See, I've captivated you. So it's not, the angles aren't bisected. So, because it's a circumcenter, from the center to what is congruent? I've written on the board. From the center to the angles is congruent. So center to the angles. So from the center to Z, from the center to Y, from the center to X is going to be congruent. So that means, the length of PZ and the length of PY and the length of PX, they're all the same. They gave us PY, and they gave us PZ, and then we want to find PX in the end. So what can we do here? Set them equal. So I'm going to do PZ first, which is 4x plus 11. Set it equal to PY, which is 5x minus 4. I always move the smaller x, which here is 4. So 11 equals 5x minus 4x is x. Add 4 and x equals 15. So is 15 my answer? Do I double it? No. Where do I do with it? Plug it back in. So which one do we want to plug it into? I think the 4 is easier. They're both, I mean, either way you're going to do it. What is 4 times 15? 60. Plus 11 is 71. So even if you had plugged it in over here, 5 times 15 is 75. And then minus 4, you would still get 71. Alright, one more. We got to decide if we have a circumcenter or an incenter. So we want to decide if we have perpendicular bisectors or angle bisectors. Lily?
Angle.
We have angle bisectors, so that means we have an incenter. Oh, shoot. So we have an incenter, which means from the incenter to what is congruent? From the incenter to the sides is mother of pearl. So that means from the incenter to the sides. So how many sides are there in a triangle? There's 3. So the distance from the center to the side, there's only 3 sides. So there's only 3 congruent segments inside of this triangle, not 4. So can someone tell me which 3 are congruent? Sam? NF, NE, and D. You are correct. So I would highlight those as congruent. You remember how yesterday we talked about the distance to something is straight there? This little line is like, what do you call it?
Looks like a flex.
No, it's like trying to mess you up.
I know.
Can't think of the word. It does not look like a flux
Yes, it
capacitor.
does. You ever seen the movie?
Yes, I've seen it.
It looked like it was like a.
That's not what the...
Giant Mercedes sign.
You're crazy. Okay, so we know that all of these are congruent. We know NE is congruent to NF, so we're going to set them equal. Why are you watching Back to the Future?
Why am I? Dude,
Have I ever seen it? I've seen all 3 of them.
I've seen some.
Cooper, Connor is an interesting person. I'm so sorry, Cooper. I just will always be sorry.
I am an interesting
Wait, did you just call me?
I called him Cooper. It's just crazy. I'm so sorry.
I have an interesting person.
Connor, we're solving math. Come on.
I know. I've already solved that, right?
Okay. So 2x equals?
14.
So x equals?
7.
Where do we want to plug it in, y'all?
6x plus 1.
Yeah. 6 times 7
42.
plus 1 is...
43.
What did you say to me? What did you say?
Lily, whenever you said which one are we gonna solve it for, she goes, one of them.
That's because she always picks the harder one. It's fine. Okay. This last one is like a common sense question that my last class bombed. So, I want you to just sit back and think. It says the length of n, can the length of n be 40? Explain. So I want you to raise your hand, tell me yes or no, and then why. Kendall.
No, because ND equals 43 and NB is a greater distance away from the point N.
Okay, perfect. You were longer winded than you need to be, but it's fine. It's no. Because, let's just dumb it down. Because NB is longer. Right? NB is longer than ND, so it needs to be a bigger number. That is all.
Yeah.
The L's on your name just throw me off.
Yeah, no, I thought she already had 2 points open. I was like,
No.
she hasn't even been answering stuff.
Boy,
He's a fetish. Okay, here's your chance. A circumcenter is where the blank intersects. Connor.
A circumcenter is where.
Don't read it. Talk to me.
A circumcenter is where the
This is what my daughter looks like when she talks to me. She's 3. She won't ever look me in the eye.
I don't remember where I wrote it down at.
Monet! Don't read it. Talk to me. Lily! The circumcenter is where the blank intersects. Perpendicular bisectors intersect. The distance from the blank to the blank is congruent. I think Logan can answer that because he is deep in thought or prayer, one or the other. The distance from the blank to the blank is congruent. What you got, Logan? Do the notes. You can do this.
Do not open your book.
You can open it, just don't read it from it.
That's what I mean.
Well, I don't want you doing this. Start talking. Does he know I'm talking to him?
No, he doesn't.
We're filling in the next blank. So distance from the blank to the blank is congruent. Yeah, distance to the center to the angles is congruent. Thank you. The in-center, Lily, is where the blank intersects.
Angle bisector.
Where the angle bisectors intersect. And the distance from the blank to the blank. Kendall?
Wait. Sorry, I was not paying attention. Center to sides.
From the center to the sides is congruent.
Aha.
Okay? So,
I had 5 yesterday. Get off.
the last thing we do is decide, using this scenario, we decide which center to use. Okay? So a school has a fenced-in area in the shape of a scalene triangle. So I've tried to draw a scalene triangle, but
It's very hard.
I'm not capable, apparently. Because it's still, whatever. You get it. It's a scalene triangle, imagine. For a new playground, the school wants to place a swing where it'll be the same distance from all 3 fences. Should the swing set be placed at the circumcenter or the in-center of the triangular playground? Explain. Well, there it goes. Circumcenter?
Is it in center?
It'd be the in-center. Because why?
It'd be in the middle of all of them.
It'd be, what's the reason?
Equal to all of them.
It'd be, yeah, equal distance. So I'm going to put equidistant. If you want to write equal distance, that's fine. Because it's equidistant.
You know there was a 50-50 shot there, and I almost had it.
Mm-hmm.
It was.
It is equidistant to the sides. I'm going to put to the fences because that's specific to the question. So it'd be equidistant to the fences. You will have a question like this on the test. Or 2. I don't remember. No, it's not hard. You just tell. It's whatever. We're doing one more. What do you mean? What? It's on the paper. Equidistant? Lamppost? I don't know. I'm pretty sure it doesn't have the red line
You
under it.
wouldn't put in center twice, so circumcenter.
Well, no, we're all going to talk about it. A city wants to place a lamppost. It's actually equidistant to the intersections, so not at the intersections. Equidistant to the intersections of the roads should the location of the lamppost be at the circumcenter or the in-center of the triangular boulevard. So first, where are the intersections? Are they on the sides or the angles? They're at the angles. You want the lamppost, it's supposed to be equidistant to the intersections. So, would we use circumcenter or in-center? We would use a circumcenter, and the reason is? That's not a good reason.
Because you said so.
Where are the intersections located? In the angles, right? Where is the circumcenter located? It's
All the angles.
from the center to the angles is going to be equal.
Oh, yeah.
Yeah,
So
that's
it's
what
going to be
It's a
equidistant.
field of angles.
Yep. So I'm going to write it's equidistant. If you want to write it's the same distance, that's fine. It's equidistant to the angles. Yes, Connor. But you didn't know the first one was an in-center, so here we are.